Hello everyone, and welcome to Jam Academy. In this example, we have two blocks, M1 and M2, on an inclined plane connected by a taut string over a frictionless pulley. We know that M2 is greater than M1 and all surfaces are frictionless. We are required to calculate the acceleration of the system and the tension in the string. We're going to treat block 1 separately from block 2. Take note about that. So for block 1, we will take our coordinate axis along the inclined plane in the direction of motion. And for block 2, we are going to do the same. This is our x, this is our y. Now the next step is for us to draw our free body diagram. We know that the weight always acts vertically downwards. So this is M1G. There is tension in the string. So this is T. Now there is no friction. There is a normal force, N. So you have here, this is M2G. There is tension in the string. This is T. And this is N1. And there is a normal force, N2 on block 2. Now the good thing is that we can resolve the weight of each block into two components. You have the component parallel to the inclined plane. This is mg sine theta, and the component perpendicular to the inclined plane. This is mg cosine theta. Similarly, you have here, this is m1g sine theta. This is m2g sine theta, m1g cosine theta. So let me just print on it. This is m1g cosine theta. This is m2. This is m2 g cosine theta. Now the diagram is a little bit overcrowded. What I'm going to do is I'm going to redraw the free body diagram right here, so that you can actually have a full picture of what's going on. So we have this is the x-axis. This is the y-axis. Remember that the x-axis lies along the inclined plane. So this will be our weight. This is M1G. This will be the tension. That is T. This is going to be the normal force. This is N1. And since there is no friction because the surfaces are smooth, we can resolve the weight into two components. This will be M1G cosine theta. This will be M1G sine theta. We're going to do the same for block 2. That is the x. This is the y. For block 2, the weight acts in that direction. So this is M2G. The tension acts in this direction. This is T. And the normal force is perpendicular to the plane. This is N2. Similarly, we can resolve the weight into two components. You have here M2G cosine theta. This angle is theta. And we have here M2G, the sine of theta. So the next step is for us to apply Newton's second law for both block 1 and for block 2. Let's start with the y. So the summation of Fy for block 1. This will be equal to N1 minus M1G cosine theta. This is equal to 0. This means that N1 is equal to M1G cosine theta. Similarly, the summation of y for block 2 is n2g m1g. This is m2g cosine theta equal to 0. This means that n2 is equal to m2g cosine theta. So let's do the forces along the x direction. If we do the forces along the x direction, you have the summation of fx. The summation of fx for 1. This would mean that t minus m1g sine theta will be equal to m1a. Similarly, the summation of fx for block 2, this will be equal to m2g sine theta minus t equal to m2a. Let's call this equation 1 and let's call this equation 2. Now, if you just add equation 1 and 2, you will clearly notice that the tensions in the string will cancel out. So we will be left with m2g sine theta minus m1g sine theta equal to m1a plus m2a. What that means is that that a bracket m1 plus m2 will be equal to g bracket will be equal to g sine theta bracket m1 m2 minus m1. So we can divide both sides by m1 plus m2, which means that the acceleration a will be given by g will be given by m2 minus m1 bracket g sine theta all divided by m1 plus m2. This is the acceleration of the system. This defines the acceleration of the system. Now the next thing is for us to calculate the tension in the string. We can either use equation 1 or equation 2. If we use equation 1, T is equal to m1a plus m1g sine theta. We know what a is, so this is just going to be equal to m1 bracket plus m1g sine theta. Now, if this is a test, you can leave it like this and you will still earn full credit. But I love to always simplify things to make them look beautiful. So we will apply some basic principles of algebra here to simplify t. So if we do that, we will have t equal to m1 m2 g sine theta minus m1 square g sine theta plus m1 square g sine theta plus m1 m2 g sine theta all divided by all of this divided by m1 plus m2. Now what do you notice? This cancels off with that. So we will be left with t equal to 2 m1 m2 divided by m1 plus m2 g sine theta. This is the expression for t. Now, this is actually a very beautiful problem. It looks complicated, but it actually isn't. You just have to be very patient with the algebra and break it down systematically. Now, if you have a question on this procedure and on this process, please do not hesitate to ask in the discussion forum below this video. Remain blessed and see you next class. Bye-bye.
Manhattan, Brooklyn.